All right, so we've been talking about logarithms, and so today we are going to be solving equations that are exponential and or logarithmic. We have to do these together because remember that exponentials and logarithms are inverses of each other. So we've seen that writing expressions in the same base can often help us to simplify them. So, for example, when we had the example where we had log base 2 of 16 to the x power, and we said we couldn't use our property where bases are the same, so the logs and bases cancel because this wasn't base 2, but we used our little trickery to rewrite 16 as 2 to the fourth. So 2 to the fourth raised to the x would be 2 to the 4x. And so by rewriting it in a different base, we could then say bases match, so the log and the bases cancel, and that would simplify to just a 4x. So that's one example of where we've used rewriting bases and that helped us to simplify it. The same thing is going to be true for exponential equations. If we can write them in the same base first, it makes the equation so easy to solve because all we have to do is set the exponents equal to each other. So that sentence right there composes our steps. First, step 1, write the exponentials in the same base. Then, step 2, set the exponents equal to each other. So, example 1a. I've got 2 to the 4x equals 32 to the x minus 1 power. Again, they have to be in the same base in order to be able to do step 2, and right now they are not in the same base. So, we're going to be writing the bigger number in terms of the smaller base. So, first thing we're going to do is we are going to write 32 in base 2. So, you have to know that's why when we first did the powers, we needed to know what's 2 to the second, 2 to the third, 2 to the fourth, and the same thing for the threes. You want to know those exponents. So, 32 is 2 to the fifth power. If you don't know that, it's going to take you some more time because you're going to have to guess and check in your calculator. So it's very helpful if you know your at least your first couple powers of each of the 2, 3, 4, 5, because those are the ones you're going to see the most. So the 2 to the 4x is staying the same, but I'm rewriting 32 in base 2. So 32 is 2 to the fifth power. Now, the exponent is going to stay the same. It was x minus 1. But now that I've made my little substitution, I've got 2 to the fifth to the x minus 1, which means now I'm using exponent rules. Now this is power of a power, so I need to multiply the exponents. Remember, when you are multiplying 5 times x minus 1, you have to distribute it. So 5 times the x and 5 times the negative 1. So 2 to the 4x equals 2 to the 5x minus 5. So first I wrote 32 in base 2. Then I used my exponent rule to simplify. Now that the bases are the same, I can simply drop the bases and set the exponents equal. And then I'm going to be able to solve. So I drop the bases, so the 2's just disappear. And I've got 4x equals 5x minus 5. Very simple equation to solve. Get all my x's on one side, so subtract the 5x. So negative x equals negative 5, which means x equals 5. And there is our answer. All right, I would like for you to pause the recording, please, and try this one. See if you can follow those 2 steps and come up with the correct solution. So pause it, go ahead and try to work it out, and then come back to check your answer. All right, so first thing I need to do is write this 81 in a smaller base to make it match. So I'm going to make this a 9 squared. So this one's staying the same. 81 becomes 9 squared raised to the 3x minus 2. So now I apply my exponent rules. So I need to distribute here. So I've got 9 to the 2x equals 9 to the 6x minus 4. So now the bases match, so I can drop the bases, and I've got 2x equals 6x minus 4. So subtract 6x on both sides. Negative 4x equals negative 4. So divide by negative 4, and hopefully you came up with x equals 1. Now, a lot of times these equations are going to be simple and linear. Please understand that they're not always linear. If you get a quadratic equation, you should know how to solve quadratics. Get them equal to 0 and either factor, use the quadratic formula, complete the square, but please know that they're not always linear. All right, moving on. When this happens and we can rewrite one exponential in the same base as the other, it's great because this is a very simple process as far as Algebra 2 level work goes. This isn't the toughest thing that we have done for sure. But we can't always rewrite numbers in the same base. So if we're solving exponential equations and we can't equate the bases, we instead are going to have to use the inverse properties. And the inverse, opposite operation, of an exponential function is a logarithm. Just like addition and subtraction undo each other, the inverse of an exponential is a logarithm. So if we can't make the bases match, then we have to take the log of appropriate base on both sides. So if the base of a power is 7, we would take log base 7 on both sides. Now, here I'm inserting what is called the change of base formula because let's just say I'm going to make up an example here that you've got 2 to the x equals 5 to the x minus 4. So I just made that up, but we could not solve this like we did in example 1 because we can't equate these bases. So if we want to undo it, and actually you wouldn't have x's on both sides, so let's just say we had 5 to the 4th. But you can't rewrite this in the same base and set them equal. So we would have to get this x down by taking the logarithm on both sides. So if the base of the power is 7, we would take log base 7 on both sides. Here, if the base of the power is 2, we would take the log base 2 on both sides. So log base 2 of 2 to the x equals log base 2 of 5 to the 4th. Now, over here, this should look very familiar. Bases match, so the log and the bases cancel. So I know that x equals log base 2 of 5 to the 4th. Now I can figure out what 5 to the 4th power is. It's 625. But even that doesn't necessarily help me because I've got log base 2 of 625. And when you press the log button on your calculator, it does log base 10. So that is why I have inserted this change of base formula here, because this is going to allow us to change a log into any base that we want. So this works for natural logs too. You can change a regular log into a natural log and vice versa if you want. You can use a natural log to simplify a common log too. But what we have is log base c of u. We can turn it into log base b of u over log base b of c. So basically, that allows us to change it to any base we want. Well, we want the two that we can actually use the button on the calculator for. So we're going to use either the common log right here or the natural log because we have a button on our calculator. So if I want to evaluate this using change of base, log base c of u. So the c part, the base, is 2. The u part, what I'm taking the log of, is 625. So using this formula, change of base, I would be able to say that x now I can say equals log base 10, the common log, of 625 over common log of 2. So I always say log of big over log of small. You always put the big number on top. So this you can actually press into your calculator. Now, I would actually like for you to try this on your calculator because I have a lot of people who press this in incorrectly and then have no idea because they're always decimals. They don't come out evenly, and so people have no clue that they got the wrong answer when they're working on a quiz or a test. So when you press this in, the key is that you either need to do it separately or you need to use parentheses around either the top or the bottom. So if I press in log of 625, I can go ahead and press enter. And that's going to tell me 2.795888, whatever. You're not going to round that. But your calculator, if you just press divided by, will take that answer and divide it by the next thing. But when you put it in parentheses. So parenthesis log of 2, close both parentheses, and press enter. So I always get people who try to punch it in and they just don't use enough parentheses and then they end up with the wrong answer and their work's right and they can't figure out why the answer isn't right. So when in doubt, it's better to use more parentheses than you need than to not use enough. So I use a ton and I do this. You can do it in one step. You don't have to necessarily do this as long as you put the parentheses around here. Now some of the newer calculators, you might not even do that, but it's better to be safe than sorry, to enclose it in parentheses so you know that you're going to come up with the correct answer. So the answer should be 9.2877-ish if you've pressed it in correctly. All right, so let's try a couple of these where we need to take the log on both sides. So all of these are exponential equations. Key on these is to get the power alone first. So on A, the power is already alone. So the key is we need to take the log of both sides because I cannot write 15 in base 4. So whatever the base of the exponential is, that's the log that I need to take. So this base is 4. So the base of my log needs to be 4. So I'm going to take log base 4 on both sides. Once I do that, I get to use my special property here. When the bases match, the log and bases cancel. So I've got x equals log base 4 of 15. Now I can use my change of base property, log of big divided by the log of the small, to come up with my solution. So again, please make sure that you are actually typing this in your own calculator to make sure you're getting the actual right answers yourself, not just taking my word for it. You should on this first one, and I should have used the approximate signs because we're rounding here. I also should have told you what to round to. Let's go to 3 decimal places. So 1.953 is what you should get approximately. All right, next one. Get the power alone first. It is alone. So that means next I need to take the appropriate log on both sides. So the base of the exponential is 5. So I need to take log base 5 on both sides. And of course I just wrote LG instead of LOG. Goodness. So log base 5 on both sides. So log base 5 of 5 to the x plus 2. Special property at play here, so the log and the bases cancel each other. That's the whole purpose of doing the inverse operation. So that's going to give me x plus 2 equals log base 5 of 22. So I can go ahead and do this log base 5 of 22 first, because I'm going to need my change of base. So log of the big over log of the small. So log of 22, and then divide that log of 22 by the log of 5. That should give you x plus 2 is approximately equal to 1.921-ish. So then you need to subtract 2 from that. Again, don't round. Keep the answer in your calculator. When the 1.92 is on your calculator, then just type -2, enter, and it automatically does it for you. So now x is approximately, it's negative 0.079. All right, C. This one is not alone first. You need to get this by itself first before you take your log. So that's the hint I'm going to give you. I want you to try this one on your own. So try C here on your own. Get the exponential term alone first, and then take your logs, and then unpause it to see what you've got. All right, so first thing, I'm going to subtract 8 on both sides. So 10 to the 5x plus 4 equals 35, take away 8, which is 27. I can't rewrite 27 in base 10, so that means I'm going to need to take the log base 10 on both sides. So log base 10 of 10 to the 5x plus 4 equals log base 10 of 27. So property cancels the log and the bases. I've got 5x plus 4 equals log base 10 of 27. Now, if when you did this on your own, you did the change of base formula, that's okay, but you did too much. And I want to stop you from doing too much. Remember that log base 10 is the common log. This one doesn't need the change of base. You can just press in log 27, and that is the answer. So log of 27, if I type it in, is, write the left side over first, 1.431. So again, don't round this on your calculator. We have to round it when we write it because we can't write all of it. But in your calculator, now to get x alone, you're going to subtract 4. So type in -4, enter on the calculator. Then you've got 5x equals negative 2.569. Then divide both sides by 5. And then we've got x is approximately equal to negative 0.514. And there we go. So hopefully you got the right answer. Again, remember that if you see log base 10, that is the common log, so save yourself some work steps and not have to use the change of base. All right, last one here. First, we need to get the power alone. So the power is e to the 0.6x, so I need to get rid of this 40 first. So I'm going to divide both sides by 40. So 240 divided by 40 is 6. So I've got e to the 0.6x equals 6. So now, in order to undo this exponential, I need to take the log of appropriate base on both sides. So whatever the base here is what the base of my log is. Now remember, log base e, we call that something special. We call that the natural log. So if I'm taking log base e on both sides, I'm writing natural log. Natural log of e to the 0.6x equals natural log of 6. Again, the natural log's base is e, so you don't have to write it, but some people like to just so they can remember that these drop out. So I've got 0.6x equals natural log of 6. Again, natural log of 6, you've got a button for that. You don't need to do any change of base. All right, so I can actually press in natural log of 6 into my calculator just as is, no change of base needed. And so then I've got 0.6x is about 1.792. Divide both sides by 0.6. So press in divided by 0.6 on your calculator. And you should get x is approximately 2.986. All right, so there is our answer. It has been said that we need to find a phrase for the ending of the video instead of that's all for this lesson. So if you have a very definitely school appropriate phrase that you would like to see as the ending message of our video lessons, you may propose it on the top of your notes, and I will take all considerations when I check these notes in class. So if you have a suggestion, if you want it to be Anchorman style, whatever you want, I will take those suggestions. Just write it on the top of your notes tomorrow, or if you want, on a separate sheet of paper. And we will use the best one for our videos from this point on. But for now, I'll just say that's it for this lesson.